Fender Blues Junior. These amps need no introduction, do they? This one is, let's just spin him round and have a look. So this is a Blues Junior 3. So this amp's in just for a bit of a checkup, but it's also in for a couple of other reasons. And you know what those reasons are. One is obviously the bias, but the other one, and not everyone knows this, but the other one is the voltage selection. So these amplifiers obviously came through the EU. They've got the EU standard voltage selection for the mains voltage, 230 volts. In this country, in the UK, Blighty, we have 240 volts. And the problem is that our mains voltage is anywhere between 235, 240 plus. An electrician told me actually that it has been known in some places to reach as much as 260, although I've never seen that when I've tested the mains voltage, and I do frequently from time to time when I'm working on amps. You can change this voltage over to 240, and I first came across this on the Rat Amps website, and the guy on there is a brilliant guy. He takes Blues Juniors and he strips out the board, and no doubt a lot of you have seen this, strips out the board and hand wires them, but he put a lot of information on there about the voltage selection and the bias problems and things. It's an interesting read. I'll leave the link in the description for this, and you can have a look. So what is the problem of having too much mains voltage then? Well, the biggest problem is that 230 volts, that's the tapping on the transformer that this is set to. So if it's set to 240 like it should be, then the heaters will, when the amp's switched on, will be at 6.3 volts. If you have it on the 230 volt setting, you'll have more HT voltage and more heater voltage, because once it gets to 230, any voltage over that will be multiplied on the secondaries. I have seen some of these amps where they've run extremely hot. Now this particular one has got JJs in it, and the original ones had the groove tubes in. I think these are JJs, yeah, I'm just looking through there. So the original groove tube ones, and you very often see them where the paint's burnt off, and the earlier ones had the white paint on the Messer tubes. Sorry, the groove tubes, not Messer tubes, what am I saying? The groove tubes had the white paint on, and it'd gone black or real dark brown. And usually what happens with this red that you perhaps can't see on there, let's see if we can hone in a bit, sorry about my finger there, see a bit more, you can probably just see the red paint coming through there. That paint is an indicator if the tubes are running too hot, it will turn brown. Actually doesn't look too bad on those, it's a bit brown on the edges, I can see there. So that's a sign that this amp is biased a little too hot. Now someone may have changed the voltage over in this already, I don't know, without till I get the back off and have a look. But what I thought we'd do is go through this amp and just do some voltage checks and just see, compare it with the mains voltage that we've got in here at the moment, and just see what sort of readings we get. So we're going to get the back off it first of all. So I'm just going to nip and fetch the cordless drill, and looking in here, I would guess this one has been changed over. In fact, Lee may have done it at the shop, because the tie wrap's missing on there, which is a first pointer. So we may be okay with this one, it may already have been changed. Now one of the other things I did on one of these amplifiers, and since then a lot of that's become more logical as they've done more and more, the Billim audio mods. So the story behind these Blues Juniors is that Fender deliberately made these amps not sound as good because they didn't want them to compete with their next range up, which would be the Blues Deluxes and things like that, the £700+ range of amplifiers, or $700 if you live in the States. And I can just see a couple of resistors there that's been, just get a pointer. And so you can see that there. So R35 is that? R35 and what's that one? Sounds like I'm at the dentist. R36. So R35 and R36 have been changed. They've been top soldered into there. So they've definitely been changed. Can't see anything else that's been changed at the minute. So I need to get the schematic out and have a look at what those two resistors are. Let's have one of those output tubes out. You can see there that the paint is a little brown on those, so I'm guessing more so in this side here. So I'm guessing they are running maybe just a shade too hot, those. Now the other thing I've found on these, that over the plate resistors on the phase inverter, because it's a long tail pair on these, there's normally a capacitor that's added to get rid of parasitic oscillation. And I have found these where the preamp tubes are absolutely shot. There's absolutely no emissions on them. Rumour has it that eventually destroys them, and there's a mod to put a capacitor, I think it might be 47 picofarad, I can't remember, I'd have to look. I've been worked on that many amps since I've done one of these. They may have, this is a Blues Junior 3, the ones I worked on were 2s. So one of the problems with these Blues Juniors was the coupling caps in them are 2 nanofarad. And just to put that into perspective, you know, your average Fender Bassman or anything like that, those type of amps, Princeton, have got 22 nanofarad. And the first time I used one of these amplifiers live, I was using a Fender Telecaster, and it was legless, absolutely legless. And at the time I'd got a Gibson SG Special, and I ended up using that guitar, and I'd got quite a bit more, you know, a bit more power, obviously, with the humbuckers. And it's much same as some of the videos that I've watched on the Guitarologist channel, where he's doing the Gibson amps, what he calls the tone sucking network. Basically just low nanofarad coupling capacitors or capacitors in the tone stack, where Gibson were doing that to keep the amplifiers clean, because they were putting their humbuckers through. And of course, when you put a Fender into a Gibson amp in those days, it just sounded weedy, which is probably why they never became immensely popular. But you should watch some of his videos, Brad the Guitarologist, because he's got some great videos on stuff like that. And he removes those tone sucking networks, as he calls them. And I have to agree with him. You know, he did demonstrate that, and they did sound dreadful, but they certainly didn't when he modded them. They sounded mint. So a similar thing going on here with these, but Fender doing it for a different reason, doing it because they want they don't want these amps competing with their £700+ range, $700 range. And believe me, when these amps are modded, they really do compete with it. They sound excellent. They really do. It's, you know, night and day. It's amazing what, you know, just changing a few components can do in these amps. And there's, you know, there's plenty of kits out there to do it, and there's plenty of guys out there, and they're probably doing it better than I am. So, because obviously some of these guys, these techs have gone, you know, whizzers have gone through these amps and instantly found all those problems. And it's easy for me when they've been pointed out, and then all you've got to do is go in and change them. Right, so I've just checked, and this amp is still set to 230 volts. And remember, this only applies if you live in the UK. So what I'm going to do is we're going to run some tests, and I'm going to show you how to change your amp to 240. But first of all, we plug this in the wall. It's gone straight into the wall, it's not into the Variac, everything. And we're just going to switch on. And we've got the meter here, which is connected to the first node at the moment. So we just, and you can see that beginning to drop now, and we have got 326 volts, and that's still dropping. So I'm going to make a note of that. Now what I'm also going to do is test what we've got on the mains at the moment. 236.6 volts we've got on the mains at the moment. So that's likely to change in the evenings because people are finishing work, places are shutting down, and there's not so much load on the grid, I would imagine. So already there's 6.5 volts too much going through that now already, from what, and surely we'd be better set at 240 with a bit less going through it. Now if that goes up to 240, then we're talking 10 volts, and that's quite significant, and I'm going to show that now by using the variac. So we look at 200, we're at 230 volts now where that's set. Yeah, 307, so 317 volts on the first node, and we've got 230 on the variac. Now let's go up to 240 on the variac, and now we've got 330 volts on there at 240. So if the mains voltage rises 10 volts, we go back down again to 230, 317, 316, 317, 240, 330. So that's risen 13 volts, that HT, which will have an effect on these tubes. So I'm going to bring that back down to 230. So the next thing to think about is the filament voltages, because if you run the filament voltages too high, then that shortens the life of the tubes considerably, and there's plenty of information to read about that online. So filament voltages should be within 5%, ideally no more than 10%. So already there at 230 volts, and you perhaps can't see that, but we've got 6.5 volts there on those filaments, so we're already over. And the variac's dropped to 229 volts. So now I'm going to put that up to the 236. It was hovering between 236 and 237, and I'm going to put that up. See if I can put this meter where you can see it. There we go. So pins 4 and pins 5. Now I've got 6.7 volts there, look. So that is over. And now we go to 240, and now we're at 6.8 volts. So that is over. And remember that the voltage could obviously creep above that. Let's see what happens if it crept up to 242. And people have seen it higher than that in this country. I've seen the voltage higher. So at 242, that's actually not, that's now 6.87, so that's pushing up to 6.9, up to 7 volts. And 243, and you can see that's 6.9 at 244. So 6.6 is 5%. So 230 volts it's set on. And we're already nearly 5% over at 230 volts, which is, again, is too much at 230 volts, because we got 236 volts going into it. But the next thing we're going to do is check the bias. Right, we check the bias on this Blues Junior. On the right side, this tube, we have 12.82 watts, and on the other side we have 14.27. Now this is a fixed bias amp, that's just idle. So this amp is idling at that. It's actually idling at more than 100%, and it should be idling at 70%. Those tubes are cooking. What that means is that when somebody plugs a guitar into this and cranks it up, the current of these tubes will go even higher, the current draw, which is why you set them at 70%, because as you start strumming the guitar, the current increases on the tubes. So the 70% at idle is to allow for that extra current increase. Lord knows what they're running at when someone's blasting away on this, amplifier at full tilt. The tubes aren't particularly well matched. They're not bad. You know, they're 1¼ watts out and something like that, a bit more than that, aren't they? 1.5 watts, but not brilliantly matched. But also, they're just frying basically. Those two resistors that we zoomed in on that have been changed, and it's not switched on, so we'll just use this. They're screen resistors that have been changed, and I need to measure those and see exactly what they are. So someone's changed the screen resistors, probably because the previous set of tubes, because I know this has had a different set of tubes in because they don't come with JJs. Maybe they've smoked those resistors out, I don't know, or they've just gone out circuit because of the excess current draw. So we need to rebias this amp, but we also need to address the voltage issues. Voltages being in the actual mains voltage. Now check this out. So this is what I've looked up online, because I thought I'd brush up on this because I really couldn't remember. Where it says in the UK, former 240 volts nominal, they are 230 volts minus 6 plus 10%, i.e. anywhere between 216 to 253. And we've got this set at 230. And if you look at the 230, which is above for European countries, that says 230 minus 10% plus 6%, so their maximum voltage will only be 243. It's the max we're really interested in. So that means that this could go well over 240 and it's set at 230. Big problems for the output tubes and the filaments on all the other tubes as well. So we've done quite a bit of testing with this, and we now know that we could end up with maybe 250 volts on there, you know, 245 comfortably, and we know that's going to push those filament voltages up to 7 volts and plus, which is too much, and the tubes aren't going to last long. Combined with being biased over 100% at idle, or one of the tubes is, the other one's a shade over 100, this amp's a disaster waiting to happen. And this is why this amp's obviously had screen resistors in, because they've gone open and you get all these failures. And then, so we need to change that voltage, and I'm now going to show you how to do that. So the first thing you do is pull out the plug, so we don't get any nasty surprises. These wires have been at because this used to have, this is all tie wrapped on them when they're new. So we'd assume that this board's been out, but obviously someone maybe tried to get this board out, found it too difficult, and then decided to do a topside repair on it. Right, so here's the schematic for the power supply settings that we've got here. And we've got the 230 volt and the 240 volt there, you can see. So all you need to change is on these diagrams to swap 230 to 240 is, if we look at white black, and that's the white wire with the black stripe down it, and we see S28, that is the switch. So what you do is you remove that wire from the switch, and if you look P6, it says black there. Now if we go on to here, you can see that P6 says white black, that's the white with the black stripe, and the switch is now black. So all you do is swap S28 and P6 around, and that will give you your voltage. So having looked at that, let's come back out and go back up here like so. Let's see how far we can get in with this camera. So it's going 2 times. Oh dear, 2 times. I think I'm just going to get the other camera to film this. So there's the wire for the switch. You can see there, that's the white wire with the black stripe. If we just hone in, see how close we can get there, that's the wire, and you can see that wire is going up to the switch. So P6 is there. If we look, and you can, if we just, I might not be able to get in very well with this camera, but this is P6, so remove P6, and that's not easy to remove, so I'm just going to put the camera. So now if we look, the black wire is in place of the white one with the black stripe, and the white one with the black stripe is now there on P6. If we just hone around there, if you can see it. Now, we've got those right and everything, according to that. But I'm still going to bring this up on the Variac. It's a thing that I do when I've changed things on the power. We don't know if we've disturbed something else, pulled something out on the board or whatever. So it's always best to use a Variac. If you make any alterations on it, I always do anyway, just for safety's sake, rather than just blasting the power on it and then you've created a fault somewhere else. We've got I've got the meter hooked back up there, and I've got this on the Variac now, so we're just going to run up gently on there just to make sure we've got everything right. Excuse the traffic there. I've got the door open. So no problems there, so we can go with the Variac. So that's 230 volts now. We've got that on. And now look at the HT voltage there. That's down to about 300 volts. 230 volts at 327, 240 we've got 316, so that's a considerable drop there. It's not a massive amount, but it's on top of the over biasing issue that this amp's got. That's just aggravating that situation even more. What we're going to do now, I'm going to use the other meter. So we're going to go down, just going to drop back down to 230. And we had 230 volts, we had 6.5 volts on the heaters on the filaments. So you can see the meter on the right. So let's just go in now. Oh, better if I put it on AC. 6.25. So they've dropped. Now let's go up to 240. And we've got 6.5, which is exactly 6.5 volts, which is exactly what we had at 230 volts. So slightly over there at 240. Mains voltage in this country generally sits around 237 volts. So that's 237 volts. 6.43. So that's pretty much bang on. So in fact, what I'm going to do now is take it out of the Variac and plug it straight into the wall. So let's check the heaters now. Just on the wall, voltage 6.47. So we are about right at 237 volts. So that now is running at 240 volts. And that's where it should be set. So those tubes now are spot on. The heaters aren't getting baked, which will shorten the life of the tubes considerably. You can read about that online. I'm not going to go into it. I have to say, when it comes to electronics teaching, I'm not very good at it. I'm all right at doing it. Teaching it's a different thing. There's guys out there far more skilled than me that will do that. We'll show you how to, explain it in a much better way than I can explain it. Teaching guitar is my thing. So what we need to do now is check the bias. With the bias on the right tube, which is this one here, we had 12.82 watts, and on this side we've got 14.27. That's what we had. So I'm now going to see just how much that has changed. And I'm now going to measure from the center tap to the plate, and that's those two there, and we've got 4.03 there. So we write that down. It says he looking for the pen. Usual thing. If I had 50,000 pens, I would still be looking for one. I'm sure there's one or two of you out there that have that same problem. Pens just disappear. I've measured the voltage from the plate or anode on the tube to ground, and that gives me 309.6 volts. I know this says 315, 316ish, but there's a slight volts drop across the transformer. So now I've done the maths on the left side, and when this was set at 230 volts, the bias on that tube was 14.6 watts, and it's now 12.8. So that's shaved off almost 2 watts just by setting that correctly. That just shows the damage that was doing, having that set like that. All these Blues Juniors, sorry, that's just going out of focus. All these Blues Juniors are set at 230 volts when they come into this country. It wouldn't surprise me if all the Fender amps are set at that, but that's wrong. So the other thing with this Blues Junior, and this is what I was saying before, is why these amps don't sound particularly great. You may think they do until you've had one modded and it's more like a Fender should be. So I've got one or two parts of the schematic that I've blown up here, so we can have a look. So the first thing is the tone stack. So if we look at the tone stack on this now, and let's see if I can do this with that and get it in focus. So if we look at the tone stack, where's that pointer going? We'll use that pen. You can see that here we've got 22 nanofarad and 22 nanofarad. Now if we look at a Fender Princeton tone stack, we've got 0.1, which is 100 nanofarad. Sorry about the light, and paper's throwing off the automatic sensor. And we've got 47 nanofarad there, 0.047. And that's one of the reasons why these amps don't sound very good. That's one of them. Also, lurking, this is back to the Blues Junior again, lurking up there is a 2 nanofarad coupling capacitor, which again is sucking out the tone, if you want to put it in the guitarologist language, which is fair comment. So these amps have got a lot of problems. The good news is they're quite easy to solve. The thing with these is, if you're competent at you know, even moderately competent at electronics, and you can get the board out, you can they're marked. So like just an example, that resistor is R15, that capacitor is C5 or C8. I'll look at that closely. I think that's C8, wouldn't be hard to find. And these hit C6, C7, so these aren't too difficult to find. You won't be able to get those out of the board without taking the board up though. So in other words, you couldn't do a topside repair, a topside change like it's been done with these screen resistors here. You would have to take the board out. And there's loads of these mods online. You know, you can go online, and I'm sure that you can go on forevermore with them. And I think one of the reasons why there's so many mods for these amps is because they're worth modding. For the simple reason is they're compact, they're easy to carry around, and once you've got them modded, they sound great. So yeah, so we need to get this board out, and we need to bias this amplifier. We need to change all these resistors, and while I'm doing that, I'm going to mod this amp. I'm going to put all the mods in it. Another mod that's done on this as well has just sprung to mind now, and if we go back to looking at this schematic again, is this mid control here, the way this is wired. where it's wired into the center tap and down to that end there. And I don't think there is a mid control on the Princeton, is there? I think it's just volume, treble and bass. What have I done with that Princeton schematic again? And I don't think we could. No, we've just got a 6000. But you see that 6800K resistor there, 6.8K resistor, sorry. That's just one end connected to the tone stack and the other end to ground. So on this, and this is what they always say, that they sound boxy, and this gets rid of that boxy sound that they have. And I must admit, when I did this mod, I did, that does ring true. So this is connected to the tone stack twice. There's got that light center tap going there, and then the wiper, sorry, there, and then it's connected on at that end and then to ground. And what you do is you simply bridge those two together, and that then makes it just a normal mid control. And that's another mod. So those two are joined together, and that gets rid of the boxy tone. So all these mods are just improving this amp. So what I'm going to do now is, before I take this board out, I'm going to snip out R52, and we're going to tag some jumpers on it, and we're going to get some more resistors of various values, and we're going to try and get this biased to 70% idle. So I've snipped the resistor there, and you can see, just about see, because it's one of those crummy 8th watt resistors, 22K that is. So we need to change that to somewhere around 30K, I would have thought, but I'm going to try 27 in first. Right, so I've cut the resistor out one side, and we've jumped in a 27K half watt resistor. I've soldered this wire on there because we'd only got a little tiny bit of wire coming out there, and if the jumper falls off it, these tubes are toast. So I've soldered that wire on, and we've got a better physical connection. The other side is the old resistor is still in, and that's holding the jumper on there much more stable, so that's okay. That resistor's out of circuit, so there's no problem. So we are now going to power this up and just see what bias we get, and also see what the HT voltage finishes up at. I don't think that'll be enough 27K. In fact, I know it won't. So I'm just going to focus on testing it on one side as well till we get it closed. There's no point keep doing both sides. So we've got a bit more HT voltage, and we would expect that. So before we had 309, now we've got 316, which tells us it's not drawing as much current. So if we go on to there, and we go on to there, we've now got a voltage drop of, still creeping up a bit because these tubes are still warming up, stabilizing, 3.27 we'll call that. So 3.27, remember the windings were 97 ohms on those transformers. Divided by 97 equals, now I've got 33 milliamps, and if we times that by our 3.316, that's now 10.65. so that's come right down. Still not down enough, but they're running a lot cooler. So we need to go again, which is what I expected. So I've now got here a 33K half watt resistor. We're going to measure it just to make sure, because, and one of the reasons you need to do this, if this resistor's faulty and it has little or no resistance on it, or it's open, those tubes will fry. And that's 32.43, so that's fine. So always check your resistor before you pop it in if you're doing fixed bias, because with no resistance on those tubes, it will be red plate time. So 33K Okay, now let's go again. Remember, these tubes aren't particularly well matched either, and again, they may have been when they were first put in, but they've been baked so much that who knows what's happened to them over that time. Now look at the HT voltage. There is now and actually, I've just remembered, I've actually made a bit of a boo-boo there when I did that first time, although it's not, I should have checked that from plate to ground, not first node to ground. My bad that, but it's only 4 volts difference, so at the moment it's not exactly critical, is it, because this thing's so far over. So we need to do we'll test again across the so what I'm doing here when I'm testing this is I'm just testing from center tap to across one side of the transformer, the plate there, and it works better if it's not on ohms, doesn't it? Duh. So now we've got 2 point, that's still, just let that settle. I think 2.56 will do for that, so we'll try that now. 2.56 divided by our 97, that now is down to 26 milliamps. We were more or less around 40 milliamps before. So you can see the other thing is to bear in mind now, that transformer's not working half so hard as it was before, nowhere near. And I know for a fact, because I actually bought one of these transformers off eBay for a project, and they are a 160 milliamps rating transformer. So 26.3 milliamps now, and let's do it properly this time. We'll take that from there and we'll pop it on there, and that's 320. Well, let's have a look at that. I'll call that 322. So 322, and I'd call that a wrap at 8.4 watts. 8.49, so it's just a little bit over, and that is 70% 8.4. So that, with that resistor in, that side at least is perfect. Right, I've just done the other side, and now these tubes are miraculously matched, almost exact. And in fact, I've actually done the settings on the left side again just to make sure I've done it right. 8.4 on the left tube, which is there, and 8.49 on the right. So now these tubes aren't being baked with an inch of their life. They've just matched up perfectly. This amp now is just running absolutely spot on perfect. No issues whatsoever. So we're going to get this board out. We're going to put that 33k in place of that crummy 8 watt resistor, which was 22k, and then we are going to look at those screen resistors, check them on the schematic, and then I'm going to put those in properly. Well, might as well while I've got the board out, and then we're going to do those mods on the EQ, and then this amp will be a result.